finally, we're going to learn something that's specifically called the second derivative test. So we were just using the second derivative to identify the concavity of our graph, but now we're going to use what's called the second derivative test to identify max and mins. So first and second derivative tests are very specific to identify max and mins. So if your first derivative is equal to 0, that means that you have a critical point, right? So that's a potential point for a max or min. And your second derivative is less than 0. Well, if my second derivative is less than 0, it means I'm concave down like a frown. So if your graph is concave down and there's a point at that in that interval where you have a horizontal tangent, it has to be a maximum. If your first derivative is 0 and your second derivative is greater than 0, that means it's concave up like a cup. And if you have a horizontal tangent at some point that's concave up like a cup, it has to be a minimum. So the second derivative test is actually really easy when it works. The problem is that there's some times that the second derivative test fails. So if you have a horizontal line, you can't really use it. You don't know what is happening. Both your first and second derivatives are equal to 0 and you need more information. It also fails if you happen to be looking at an inflection point, because again, usually our inflection points are not max and mins, but they will not be concave up or concave down, so we can't use the second derivative test. Okay, same example we used before when we had f of x equals x to the fourth. We know that that graph has a minimum at x equals 0, but the second derivative test fails because look what happens. So first I have my first derivative, I set it equal to 0. I say, oh great, my critical point is at x equals 0. Okay, so it could be a max or a min there. Then I take the second derivative and I evaluate it at the critical point, and I still get 0, which means it doesn't have concavity at that point. So because it's confused, in other words, it can't evaluate that. So the second derivative test fails, as we said. So when this happens, that would tell you have to go back and do the first derivative test. Okay, that will solve that sort of situation for you. But let's see how easy the second derivative test is if it works. So let's see what happens. Use the second derivative test to find max and mins. All right, so first, I always have to find my critical points based on the first derivative, because the first derivative critical points are the ones that tell us that I have a horizontal tangent. And so those are going to be my potential max and mins. So I have a potential max and min at x equals -2 and x equals 2. If I was doing the first derivative test, I would now do sign testing of the first derivative, right? But the second derivative test can really be even easier. So I take the second derivative now of my function, which is 6x, and I'm going to evaluate. I don't actually sign test. This I actually plug in to the second derivative. And look, at x equals -2, I find that my second derivative is negative, which means that my graph is concave down like a frown. So what did I just find out? At x equals -2, I have a max. If I plug in +2 to the second derivative, I get 12, which is greater than 0. That tells me that my graph is concave up like a cup, which means that I have to have a minimum. Okay, so the nice thing about the second derivative test is you actually don't have to sign test. So let's see how we would do this. I have a maximum of, you get the y value 11, at x equals -2. So I state my fact. Because, so I have to state 2 reasons because this is a point. So how did I know that -2 was a critical point? Because f prime of -2 was 0, so that was a critical point. And now how did I decide that it was a maximum? Because f double prime of -2 was less than 0. I have a minimum of -21 at x equals 2. Why? Because 2 reasons. I knew it was a critical point because its first derivative was 0. And I knew that it was a minimum because its second derivative was greater than 0. And that is the second derivative test.